Hey everyone, on this lecture we are going to continue studying the fundamentals of normalizing text in natural language processing. On previous lectures we already saw how we could transform text into lowercase. Nevertheless, there is often a desire to extend this normalization further by removing any word affixes, and this process is usually known as stemming, and it is very important in natural language processing. In addition to the stemming process, an additional refinement involves verifying that the resulting form that we get corresponds to a recognized word in a dictionary. This process is known as lemmatization. So now let us suppose that we have the following text and we want to normalize this text. So let us now first of all create a new notebook. We are going to import the natural language toolkit library. And so in this lecture, we are also going to need to tokenize our text so that we are going to download the PAM tokenizer models. This is a pre-trained, unsupervised machine learning model for tokenizing text into sentences or words. Once we have downloaded this PAM tokenizer models, we can now import the word tokenize function from the natural language toolkit library. So from the natural language toolkit library and from the model tokenize, we are going to import the function word tokenize. This function is used for tokenizing a text into words. Finally, as we'll see, for lemmatization, we are going to need to use a function with the name WordNet lemmatizer. In order to use this function and any function of this class, we need to download this WordNet data from the natural language toolkit library. So here we also download this WordNet data. Very well, and with this we have all of the imports ready. We can run this window, and now let us continue. First of all, what we have is the raw text, which is this text in here, right? We want to normalize this text, so let us just copy this raw text and paste it as the value of this variable raw. Now notice that once we have the text or any raw text, we can easily obtain the tokens of this text using the function word tokenize on this text. That, remember, this is the function that we imported previously, right? Remember that tokenization is the process of breaking down a text into individual units, which can be words, phrases, sentences, or any other meaningful elements. In this case, we are tokenizing this text into words. Notice that when we run this cell, we're going to have the words inside this token. So we're going to have a list. In fact, we can here just print it. Let us run. And notice that here we are tokenizing this text into words, right? We have original, and we have here pay. We have also the column previously. Tension, comma, peculiar, individuals, reclining, in legs, and so on. So once we have this text tokenized into words, we can now begin the stemization. So this is the process that involves reducing words to their base or root form, called the stem. We already studied previously in the course stemization. Remember that the stem is the part of the word that carries its primary meaning. Right? For instance, the stems of the words running and runner are run in both cases. This is the root of the word. So the natural language toolkit library includes several of the shelf stemmers. One of the most used and efficient ones is the Porter stemmer. So now let us define this Porter stemmer. This is a stemmer that belongs to the natural language toolkit library, and here we just type Porter stemmer. So this refers to the Porter stemming algorithm implemented in natural language toolkit library. And this Porter stemming algorithm is one of the most widely used stemming algorithms in natural language processing. So once we have this Porter stemmer algorithm, let us now apply the stemization for all of the tokens in the list of tokens. So we can do this with a comprehension list. So we are going to apply the stemization for all of the tokens T, for T in the list of tokens, which is here this variable. So with this, we create an instance of the Porter stemmer class. And once we have an instance of this class, we can apply the method stem to a specific word, to a specific token, so that we can perform stemming into this token. So let us now run this cell and visualize the result. Okay, so notice that if we compare this result, this new result, of the of the stem tokens and we compare to the original list of the tokens, here we can see we have, for instance, pay, we have attention, right? Let us compare the first two results. So here we have pay, okay, this is the root of the word, right? The verb to pay, and then but here we have attend, because we are taking the root of attention. The root of attention is not attention, rather it is attend, right? If we look at peculiar, we can see we get, okay, also peculiar. If we look at individuals, we get that the stem, the root is individual. If we look at in here reclining, the stem is recline, and so on and so forth. So here we have all of the stem tokens from the original text. And with this, we complete the stemization phase. Let us now delve into the lemmatization. Notice here how some of these stem words are not recognized words in the dictionary. Thus now we are going to transform all of the tokens, we are going to reduce all of the words to their base or the dictionary form, that is the lemma. So very important to notice that the stemming and lemmatization are distinct processes as they serve different purposes. The stemming reduces words to their base or root by removing the affixes. In the lemmatization, we reduce the words to their base or dictionary form, that is the lemma. So in order to apply lemmatization, we are going to use the WordNet lemmatizer. That is why we downloaded a WordNet database. So here let us define the WordNet lemmatizer as WNL, for instance, to be an instance of the WordNet lemmatizer, which is this class in here. So we are defining, okay, WNL to be an instance of this class. And so now we can lemmatize all of the tokens that we have in the list of tokens in the same way as we did before for the stemming process. We can use comprehension list. So here, let us lemmatize. So we access the instance of the class and we use the function called lemmatize. That given a token, it is going to lemmatize this token. Given a word, it is going to lemmatize this word. That is, it is going to reduce this token, it is going to reduce this word to their base or to this dictionary form that the word has. So we are going to lemmatize all of the tokens t, okay, for t in the list of tokens. Hence now if we run this cell, we can see how the result we have all lemmas. In fact, if we here, okay, compare the tokens, which are these ones, if we compare, for instance, individuals, okay, to the lemma, we can see that the lemma of individuals is individual. If we compare, for instance, the token lakes, which was the original token in here, right? The lakes token, and we have the lemma. Here we can see how the lemma is lake, which is the dictionary form of this noun. So here we can generalize this. If I have a text and I have transformed this text into a list of tokens, right? Then we can lemmatize this text, so we can get the dictionary form of all of the words of all of the tokens. And this process of lemmatization plays a vital role when normalizing text in natural language processing. Very well, with this we end this brief lecture on normalizing text. We remind the student as always that you can download the solution and all of the implementation of this lecture, as well as the documentation on the downloadable documents of this lecture.